Hello all. In this video session we will be discussing about storage classes. First of all, let's discuss a few concepts related to storage classes. First one, scope and lifetime. Now scope of a variable refers to the visibility or accessibility of a variable at a particular region in a program. Okay, so scope tells us whether a particular variable is accessible at a particular region in a program. Okay, and lifetime of a variable is the time for which variable is alive. That is, the memory is reserved for the variable uh, while the program is executing. The time for which memory is reserved for the variable while program is executing. Okay, so now just we'll go through an example to understand scope of variable. I think in the previous lectures we have seen scope of variable, two scopes, that is local scope and global scope. Okay, so we'll see one example. So here I have declared one variable g equal to 5 outside all blocks and functions. Okay, so any variable that is declared outside all blocks and functions are global variables. Okay, and if we declare a variable inside a block, then it will be local variable. Okay, it will be local variable. Okay, so in this example here g is a global variable and L is a variable declared inside the function display. So L is a variable local to the block starting from here to here. Okay, now we have a display function for displaying L and G, and we have main function inside which display function is called, and also L and G is and also we are trying to print L and G. Okay, so the program execution starts with main. Okay, before that, if we have any global variable, once during the compilation phase the memory is allocated for the global variable. Okay, so consider that it is allocated, or we are assuming that it is allocated at address 100 and it is having a value 5. Okay, so when program execution begins, control comes here, then this display function is called, so control comes here, then after that when it comes to this line, this statement will be executed and memory will be allocated for L. Okay, so it will be having the value 10 and we are assuming that it is at address 300. Okay, so now this L is declared, then after that value of L is printed, so 10 will be printed, then value of G is printed, so 5 will be printed. And here you have to observe that here G is a global variable. So the specialty of global variable is that global variable is accessed everywhere inside the program. Okay, so global variable will be having an file scope, that is, if it is this program file is prog.c, then G is accessible everywhere inside the program prog.c. Okay, that is what you mean by global scope. Okay, it will have a global scope that is accessible throughout the program. Now here the variable L is declared inside the display function, so inside this block, so it will be only accessible inside this block, and this L variable or local variable will be only alive while it is inside this display function, since it is local to the display function or local to the display block. Okay, but in the case of global variable G, it will be alive till the end of the program, so its lifetime is the entire program. Okay, so now the execution is has reached here, so LNG is printed, then after that control from here goes to here, so this memory will be deallocated, so the scope and lifetime of local variable L ends after execution of display function. Okay, so it is destroyed, then control comes here, and then we are trying to print L, but L is not existing, so an error will be displayed. Okay, this is because L is having local scope and its lifetime is only till the control remains inside the block in which it is declared. Okay, and then we'll printing G. So since G is global, we can access G here. So 5 will be printed. Then after that, return 0 statement will be executed. Okay, and the function will finish returning a value 0. Okay, so the main thing that we have learned is a local variable is a variable which is declared inside a block. Its scope will be only inside this block, and also its lifetime will be only inside the block until the control remains inside this block. Okay, so there is the scope, that is scope of variable L or local variable is only within the block, and okay, so local variable, scope of the local variable will be only inside this block, and it will have scope only until the control remains in this block, and then its lifetime will be only for the time for which this block is executed. Once this block has completed execution, it will be destroyed. Okay, or this variable will die out. But in the case of global variable, it has a global scope, or we can say it is accessible anywhere in this file. Okay, and its lifetime will be entire program. So this memory will be allocated once compilation is done, and after that it will remain in the memory till execution is over. Okay, so from the beginning to the end, memory will be reserved for G, and this will be existing there. Okay, so remember about local and global variables. Okay, now next we will see, okay, memory will get destroyed. Okay, next we will see the memory layout of C program. So we know that we have object code, that is the program written in high level language is converted into an executable format. Okay, there are few intermediate steps, but anyway it will be converted to an object code. So in the default memory layout of C program, first it will have a text segment inside which object code is stored, and then there will be a data segment in which all the initialized global and static variables are stored, and it has a BSS segment in which all the uninitialized global and static variables are stored. And the significance of BSS segment is that all the uninitialized data stored inside BSS will have the default value 0. Okay, then we have the heap segment inside which all the dynamically allocated memory are stored inside heap, and heap will grow upward. And then there is stack segment, all the local variables and return addresses are stored inside this stack segment, and this stack grows downwards. So once this stack grows downwards or heap grows upwards, and when these 2 points meet, then it may cause a memory overflow. Okay, so just remember the memory layout of C program. We have text segment, data segment, BSS segment, heap segment, and stack segment. Okay, now we will see what a storage class is. So like a data type is there is a data type for a variable. Every variable is also concerned with a storage class. A storage class defines the scope of the variable, the lifetime of a variable, and where variable is stored, or the location where the variable is stored. Okay, so remember these 3 points. Then there are 4 storage classes in C: automatic, register, static, and external. Okay, so we will see each one of them. First one is automatic storage class. So automatic storage class is the default storage class for variable declared or defined inside a block or function. Okay, so it is the default one. So even if no keyword is used, it will be of automatic storage class when we are declaring a variable inside a block or function. Anyway, the keyword used is auto. So it is defined inside a function or a block. Block means a pair of parentheses. Then these automatic variables are stored in our RAM and in a section called stack segment. Okay. So they are stored in the stack segment and they will be having a garbage value as default initial value. Then its scope will be local scope, that is it will be only visible in the region or in the block they were declared or defined. Okay. Then what is its lifetime? So it will be alive until the control remains within the block, or we can say that until block in which it is defined is executed, it will have life. Once that block of code has completed execution, it will die out. Okay, so this is an example given. So we can declare automatic variables inside a function or a block. We can either use auto. If no auto keyword is used, then also it will be considered as an automatic variable. We'll just see an example. This is our main program, and here inside block I have declared I. So this variable I will only have scope and lifetime inside this block. Outside it won't have any scope. Okay, so just consider that program execution starts, control comes here, then comes here. So memory is allocated for I. Assume that it is allocated at address 500. It is having value 1. So 1 will be printed, and once this block of code has completed execution, this variable will die out, and after that when this statement is executed it will show error because I is not existing anymore. So always remember that automatic variables are local to the scope in which it is declared, and also its life is only within the block in which it is declared. So once all the codes in the block in which it is declared has completed execution, it will die out. Okay. Now this is one more example. So this example using function. So okay, here is a display function and main function. So the control starts or execution starts from main function. Then when this statement is executed, memory is allocated for n. Let's say it is allocated at address 100. It is having value 1. Then display function is called. So control goes from here to here, and then once it is here, then this variable or this n variable doesn't have scope in here because it is blocked inside, it is declared inside this block, so it will only have scope inside here. But if you observe, the control has transferred from here to here, so there are two more statements remaining. So this block of codes has yet not been executed completely, so it will be alive, but since control is here, it won't have any scope, or n is not accessible from this region. Okay, so when control comes here, this statement is executed, so memory is allocated for num and 5 is stored there. And after that we are trying to print n. N is alive, but n doesn't have any scope here, so it will show an error. Okay, so once this statement is also, or this block of codes are also executed, the control will come from here to here, and once control comes from here, this memory will be deallocated, or this variable will die out. Okay, and once the control is here, we are trying to print num. Now num doesn't have any scope here, so it will also show an error. Okay, so once the program has completed execution, this memory will be deallocated as well. Now the next storage class is register storage class. The keyword used is register, and register variables variables register storage class are defined inside a function or a block. Block means a pair of parentheses, and they are stored in registers. Okay, so all the register storage class variables are stored in register, unlike other storage classes where they are stored in our RAM. Okay, and the default initial value is garbage value. Then scope is they will have a local scope, that is they will be local to the block in which the variable is defined. Then its lifetime is till the completion of those block of code. Okay, so the example is we will be using the keyword register, then data type variable. Okay, if we are giving an initialization, we can give equal to value. So this will be given inside the block of code. Okay, so we'll see an example. So we have main function, and inside this variable I is declared, and here we are using the keyword register. So this memory for I will be allocated or will be stored in registers. Okay, so it will help us for faster execution. And the one thing that you have to remember is that we have limited number of registers. So if we declare a lot of variables register, more than the processor can accommodate, then the remaining variables will be taken as automatic variables or variables with automatic storage class. Okay, next one is static storage class. For declaring a variable as static, we will be using the keyword static. There are internal static variable and external static variable depending upon where they are defined. If we are defining the static variable inside a function or block, then it is an internal static variable. If we are defining a static variable outside all functions and blocks, then it is an external static variable. Okay. Now its storage location is in the memory in the place called data segment for initialized data or BSS segment for uninitialized data. Then the default initial value of static variables are 0. Then scope, local scope for internal static variable and global scope for external static variable, that is they will be accessible throughout the program. Throughout the program means if we have a prog.c, then this global or external static variable will be accessible throughout the file prog.c. Okay, then the lifetime of static variable is entire program. Okay, so always remember static variable, whether it is local or global, it will have a lifetime of entire program. Okay, there one example is given. Okay, we will just go through the program. So here we have a static int which is external static variable. Then we have a function fun in which another static variable I is declared and initialized. So it is an internal static variable. Then we have a show function in which a non-static variable or an automatic variable, since no storage class is mentioned here, so it will be an automatic variable with automatic storage class is also declared here. Okay, declared and defined here. Okay, and we have a main function calling these functions. Okay, so the execution, so once when the execution starts, before the execution starts, memory will be allocated for n and memory will be allocated for I. Let's assume that I is stored at location 40 and n is stored at location 60. I will be having an initial value of 10. Okay, then no value, initial value for n is given, so it will be initialized, or it will be having the value default initial value 0, since it is a static variable. So then execution starts from main. Show function is called, so control comes here. Okay, once execution starts, the control is not inside fun, so this won't be having any scope here. This is a internal static variable or local static variable, so it will having scope only inside this block of codes or only inside this block. Okay, so control is here, show function is called, so control comes here, then control comes here, memory is allocated for j will having 10, j plus plus, j is incremented to 1, then this statement is printed. So inside show 11 will be printed. Then after that this statement has finished execution, so memory will be deallocated or the variable will die out. Then again control comes here, then function fun is called, so control comes here. So once control comes here, this will have scope. Okay, then after that this statement, okay, this statement is only executed once when the memory is allocated. After that this statement won't be executed, so the statement will be coming to here, or control will be coming to here. Okay, you have to remember this point. This static int I equal to 10 will be only executed once. After that it won't be executing. Okay, so here control comes here and I is incremented by 1, I becomes 11, then this will be printed inside fun 11. Okay, then after that control, once execution of this is over, control comes to here and this will become again inaccessible, and then show function is again called, control comes here, memory is allocated, again memory is allocated for j, Okay, we are assuming it is allocated at 200. It may be allocated at some other locations depending upon the memory availability. Then again, j is incremented, so j becomes 11. Okay. Then after that, the statement is printed. So inside show 11. Okay, that will be printed. So after that, execution of this, all the statements in this block, all the statements in this block is completed. So this variable will die out and control comes here. Then again, fun function is called. Again, this variable is becomes accessible and the statement won't be executed, and then I is incremented, so I becomes 12. Then the statement executed, so inside fun 12 will be printed. Then after that again control comes to here, so it won't be having any scope. Then once this has completed execution, both the variables are deallocated. Okay, so the static variables, you have to remember that static variables can have local scope or global scope. Okay, internal local scope and external global scope. And in the case of lifetime, all the static variables will be having lifetime of entire program. So they will be available in the memory till end of the program. Okay. Now the next one is external storage class. External storage class we mainly use for global variables. Now here we have the keyword extern and it is defined outside all functions and blocks. So the storage location will be in the memory. For initialized data they will be stored in data segment. For uninitialized, if they are uninitialized, then they will be stored in BSS segment. Their default initial value is 0. Then they have a global scope, okay, and they have the lifetime of entire program. Okay, we will just explain it with the help of an example. Okay, so now consider that main.c and prog.c are part of same project. Okay, we had discussed about modular programming, and in that we will be having multiple files, multiple C files, and only one C file will be having the main function. And here the use of the extern keyword is that if you observe, we are combining all these files and executing. Okay, so main.c having this code and prog.c having this code, and inside main.c I want to access this global variable num. Okay, now this num is a global variable declared in prog.c, so it will be accessed, it can be accessed anywhere in the program prog.c, but it is not accessible in main.c. So if we want to access this num, we have to tell that to the compiler, and we do that with the help of the keyword extern. So here this extern int num means that we are telling the compiler that I am using a variable num of type int, which is an external global variable, which is an external variable which is external to this program. Okay, so here this is actually not a declaration. Here we are not declaring a new variable num, we are just telling the compiler that extern int num, that is external to this, there is a variable num or a global variable num that I am going to use. So once you use this statement, what it does is that there is a part called linker which will go through the code and find out any global variable named num. If there is a global variable, then it will reference this num to that particular location. Okay, so extern is used for linking global variable stored in, or is used for linking global values stored on other C files in the project. Okay, so remember about that. So this, with the help of this extern keyword, we can use global variables that are declared in other programs of same project. Okay then, thanks.